Okay, so sometimes these motion problems are a little tricky. I'm going to show you a little bit different technique on this one than I did on the last one. And you can find more examples in the book. You may prefer one way over another, but we just want to get the right answer. There's more than one way to do these problems. Okay, so Kayla rode her bike 75 miles home from college one weekend and then rode the bus back to college. It took her 2 hours less to ride back to college on the bus than it took her to ride home on her bike. And the average speed of the bus was 10 miles an hour faster than Kayla's biking speed. Find Kayla's biking speed. So that's what we're looking for, Kayla's biking speed. Okay, so we're going to set up our chart. And oftentimes in these motion problems, you've got two things going on. You've got uphill, downhill, with the wind, against the wind. This time we've got her going on her bike, we're going on the bus. Okay, so she's going on the bike. But on all these problems on our chart, we have rate times time equals distance. Okay, how fast does she go riding her bike? We don't know, that's what we're looking for. So I'll say B for biking speed. We're going to leave the time column alone for a minute, and that's the part I'm going to show you. And then how far does she go? Well, to get home on her bike, she has to go 75 miles. All right, then she's coming back to college on the bus. We know a little bit about the speed of the bus. We know it's 10 miles an hour faster than Kayla's biking speed. So B plus 10 would be the rate of the bus. All right. And we know the distance. We know it's just as far for her to go home as it is to go back to college. So 75 miles to go home by bus. And then here's what we do that makes it a little bit different. We know that rate times time equals distance. And so what we're going to do is we're going to divide both sides by r and say that time is equal to distance divided by rate. Okay? Now in this case, they talk about it taking her 2 hours less to ride back to college on the bus than it took her to ride home. That's where our equation is going to come from. So we're going to use this idea of time as distance divided by rate. So in our time column, we're going to take the distance, 75, and divide it by the rate, b. And then that's how long then it takes her to go by bike. Then we're going to do the same thing in the bus row. It's 75 miles, that's the distance, divided by b plus 10. That's going to be how long it takes her to go by bus. So this is the time column, okay? Now, we've got Kayla going home. So she's biking by bike. And it takes her 75 divided by b. That's how long it takes her to get home on her bike. And then we have going back to college by the bus. And we know it takes her 75 divided by b plus 10. That's how long it takes her to go by the bus. Now, here's how I usually think of it. I think about, well, which one's faster? The going on bus is faster, right? Okay, so maybe it takes her 5 hours to go by bus, but it takes her 7 hours to go by bike, you know. So I think about, I want them to be equal to each other. So if I want them to be equal, what would I add to make them equal? This is the slower time right here, or the longer, I should say longer time. It takes her longer to go on the bike than it does on the bus. So I'm going to add the 2 hours to the bus ride. Then they would be equal to each other. Another way you could do it is to subtract the bike time minus the bus time, and that would equal 2 hours. That would be another way to do it. So whichever way makes more sense for you. Okay, you're going to get the same equation. Well, the great news is this is a rational equation. It's not a proportion, so that's kind of sad, but it is a rational equation that we've been solving. And so what's the LCD? The LCD is b times b plus 10. So we're going to multiply this by b times b plus 10. And then we're going to multiply over on this side times b plus 10. Now I think in the last section I always distributed, but I didn't this time. Okay. So the b's cancel out there. So I have b plus 10 times 75. And then over here I'm going to have 75 times b plus 10 over b plus 10. So I'll write it out so you can see it. And 2 times b plus 10. Okay, last up. Those b plus 10s cancel. All right, now we're getting somewhere. All right. So I'm going to have b plus 10 times 75. I'll do all the distributing on the next line. And then 75b plus 2b times b plus 10. Okay, now I want to do the distributing. So distributing in here, I get 75b plus 750. And then over here I get 75b plus 2b squared plus 20b. Okay. I hope you have lots of paper. Okay, now we'll just keep going. I was going to do something tricky, but I won't. Okay, combining like terms, you've got 75 and 20, 75b and 20b, so 95b plus 2b squared. Okay, we'll subtract the 75b. And then we're also going to have to subtract the 750, so we might as well do that now. Okay, it's a quadratic equation. I don't think I mentioned that yet, so it's quadratic. So we're setting it to 0, so 0 on the left this time. I'm going to write the 2b squared first. Then I'm going to have plus 20b minus 750. Okay, all of those are divisible by 2, so you could take out the GCF of 2. Or if you want to make it a little bit easier, you could just divide everything by 2. You're allowed to do that. 2's not 0, so you can do that. Then you don't have to write the 2 anymore. Oh, how many times does 2 go into 750? 375? That's right. Okay, now I'm thinking AC method. Oops. Well, not even AC method. So I'm multiplying to get a negative 375. Not sure what that's going to be. And I want them to add to be 10. I know 25 goes into 375. So I'm going to start with 25 times something. Let's see. It's going to go 1. Let me think about this a minute. 12, 15 times? Ooh, I might have gotten lucky. Now, I would check and make sure that my 375, I'll check that real quick. 375 divided by 25. Pretty sure it's 15. It is. Okay, so good news. We found the numbers right off the bat. So I kind of got lucky there. You know how I got that was, because some of you might be saying, how did she get that? I was thinking about money, and that if I had $3.75, I know I could make that in quarters. So how many times does 25 go in? Whoops. I don't want the negative on the 25. I want the negative on the 15. Okay. So 25 and a negative 15, that will multiply to be negative 375, and it will add to be 10. So great. So this factors into b plus 25, b minus 15. And b was the biking speed, so just as a reminder. Now, if we set those equations, b plus 25 could equal 0, or b minus 15 could equal 0, then you get b equals negative 25 here, and you get b equals 15 here. But this is a biking speed, so she's not going negative miles an hour. She's not going backwards. So her biking speed is 15 miles an hour. Biking speed, 15 miles per hour. And that's what the question asked. If they wanted to know the speed of the bus, it's 10 miles an hour faster, so it'd be 25. But they just asked for the biking speed.